Today, we're tearing into one of the most brilliant, yet honestly completely overlooked pieces of engineering hiding right under your hood. If you want to know the true secret to a whisper quiet, smooth ride, you are absolutely in the right place. We're talking all about hydraulic engine mounts. Let's dive right in.
You know the feeling, right? You're sitting at a stoplight, hands resting on the wheel, and out of nowhere, your perfectly fine car starts buzzing, like vibrating like an old farm tractor buzzing. It's a hugely relatable frustration. You might immediately panic and think your engine is failing, but actually, the invisible culprit behind that steering wheel shake usually isn't the engine itself. It's what the engine is sitting on.
So, here's our roadmap for this explainer. 1. Beyond a simple rubber block. 2. Inside the hydraulic engine mount. 3. Warning signs of mount failure. 4. How to test your mounts. And finally, number 5, rules of proper replacement. We're going to quickly demystify the complex engineering and then get into some really practical, money-saving advice. All right, kicking things off with Section 1, Beyond a Simple Rubber Block. Okay, it's time to shatter a massive automotive myth right out of the gate. Your engine is not just sitting on some dumb hunk of rubber. Modern vehicles use engine mount fluid damping. This means there's actually hydraulic fluid inside the mount actively absorbing and converting vibrational mechanical energy into heat. That is the real magic here. Notice the difference between just isolating and actually converting. A plain rubber block might isolate a vibration, but a fluid-damped hydraulic mount literally destroys that vibration by turning it into heat through fluid resistance. Moving right along to Section 2, inside the hydraulic engine mount.
Let's peel back the metal and rubber and see what's actually going on in there. It's wild how this tiny space holds such a sophisticated dual-stage system. You start with the outer structural rubber body, which, keep in mind, is supporting massive powertrain weights, sometimes over 400 kilograms. Inside that, you've got an upper pump chamber and a lower compliance chamber. Filling those is a highly specialized glycol or silicone-based hydraulic fluid. Connecting them is an internal inertia track right alongside a free-floating rubber decoupler membrane. And those last two, absolute superstars.
Here's exactly why they are the superstars. You see, an engine throws out wildly different vibrations depending on what you're doing. Sitting at a stoplight, that rough, low-frequency 5 to 15 hertz shake is wrestled by the inertia track. It forces fluid through a tuned, restricted passage, and that viscous resistance just kills the large amplitude shake. But on the highway, once you hit 50+ hertz, the fluid actually locks up from inertia. If the fluid had to do all the work, your mount would feel like a solid rock. Enter the free-floating rubber decoupler membrane. It deflects just micro amounts to filter out that rapid highway road noise without forcing fluid through the track. It is a brilliant dual-mode setup. So, what does this all mean for stiffness? Well, because of this dual-stage design, the dynamic stiffness of the mount can intentionally spike to be 3 to 5 times higher than its normal static stiffness. Basically, when the engine tries to shake violently at idle, the mount dynamically stiffens up via that fluid resistance to actively cancel it out, and then totally relaxes to stay soft for high-speed cruising. I absolutely love this perspective from an automotive engineer. Quote, "Better isolation requires a soft mount. Better damping requires controlled stiffness. The inertia track and decoupler system allows both objectives to be met simultaneously." End quote. It perfectly sums up why these hydraulic systems totally outclass standard rubber mounts. Engineers are essentially fighting two completely opposite physical needs, and this elegant internal fluid and membrane design solves the puzzle beautifully. But you know, none of this matters if the fluid freezes solid in December or boils in July, right? Luckily, the specialist hydraulic fluid inside maintains a highly stable viscosity from -40 degrees Celsius all the way up to a scorching 120 degrees Celsius. This ensures you get consistent vibration control no matter the extreme temperatures outside. Whether you're in a winter blizzard or desert heat, the fluid keeps its damping power and the ride stays perfectly smooth. All right, that brings us to Section 3, Warning Signs of Mount Failure. So we know how smart these things are, but what actually kills them over time? Heat is a massive one. Nearby exhaust components slowly bake the rubber. Oil contamination from engine leaks is another huge enemy because oil degrades rubber super fast. Throw in some aggressive driving, towing, or poor engine alignment, and you are really accelerating the wear. Typically, you can expect an 80,000 to 150,000 kilometer lifespan, but if you do a lot of extreme driving, you definitely want a tighter, practical service schedule because heat and fluid leaks will slash that timeline significantly. Now, you might want to mentally check off what your own car is doing as we go through these early warning symptoms. Are you feeling excessive vibration or a buzzing in the cabin at idle? Do you hear a metallic clunking sound when you're shifting gears? What about visible oily, clear, or yellowish fluid residue under the hood? Or maybe just increased noise and harshness at highway speeds? That last one actually points straight to a failed decoupler membrane. Basically, these are your car's cries for help. And we absolutely need to talk about why you can't just ignore this. If a fluid mount fails, it basically becomes a collapsed, useless block of rubber. All that raw, violent engine vibration goes continuously straight into the chassis, and this creates a devastating domino effect. It fatigues and destroys really expensive secondary drive time parts. We're talking snapped exhaust flex pipes and torn up CV axles. Getting those mounts swapped promptly is literally saving your wallet from massive secondary repair bills.
Let's move on to Section 4, how to test your mounts. Okay, let's empower you to check this yourself. You don't need any special tools for this. First up is the engine rock test. Now, please follow these safety precautions carefully. Park safely, set the brake, and put the car in neutral. Stay completely clear of the engine bay and have a helper lightly rev the engine while you watch from a safe distance. You are looking for more than 5 to 10 millimeters, so about a centimeter, of engine movement. If that engine looks like it's trying to jump out of the hood when the gas is pressed, your mounts are heavily degraded.
You can also run a quick checklist of 3 simple spot checks without removing any heavy components. First, a visual inspection. Grab a flashlight and hunt for any yellowish or oily fluid seepage around the mount body. If it's leaking fluid, it's a definitive failure. Second, physical touch. With the engine completely cool and off, press on the mount. If it feels collapsed or unusually soft, it's done for. Third, an audio check. Listen for constant metallic rattling or gurgling when you accelerate. Pro tip here, I highly recommend doing a quick visual check for leaks during every single routine oil change so you catch this stuff early.
Finally, let's wrap up with Section 5, rules of proper replacement.
All right, so you found a bad mount. Now you need to fix it, and you really need to avoid bad mechanic advice here. Matching the original OEM hydraulic specifications is absolutely critical. If a mechanic tells you to just slap in a cheap solid rubber mount to save a few bucks, don't do it. While an OEM hydraulic mount maintains your factory ride quality, gives you that 3 to 5 times dynamic stiffness, and actively dissipates energy, a cheap solid rubber one literally ruins the original ride quality. It dramatically increases idle noise and harshness and transmits continuous vibration right into your seat. Substituting active hydraulic systems with plain rubber is a massive downgrade. And here is a crucial piece of professional advice to write down. Always, always replace hydraulic engine mounts in pairs. Think about it. If one side failed from age and heat cycles, the other side has experienced the exact same mileage. If you only replace one, your engine is left unevenly supported. That ruins the overall vehicle balance and basically guarantees your brand new mount will wear out super fast because it's working overtime to cover for the old one. Which leaves us with one final thought. Is the money you supposedly saved on a cheap, solid rubber mount really worth the cost of a shattered exhaust flex pipe or a broken CV axle a few months down the road? The engineering inside these fluid-damped mounts is working incredibly hard every single second you drive, just to protect your drivetrain and give you a luxurious ride. Treat them right, match those OEM specs, maintain them properly, and your car will definitely thank you.